Data Skeptic is the official podcast of dataskeptic.com, bringing you stories, interviews, and mini episodes on topics in data science, machine learning, statistics, and artificial intelligence.
When I was at NIPS last week, I bumped into Rigel Smiroldo, a principal engineer in machine learning at Mercedes-Benz Research and Development North America. We sat down and talked about how Mercedes-Benz is using machine learning inside the car and how they're working to bring such innovations to market.
So I'm a principal machine learning engineer, and I am part of the user interaction group. We sort of have on our plate, the term that we use is sort of end-to-end sort of responsibility. And what we mean by that is that we go from everything from the theoretical fundamental research to sort of the proof of concept stage and the prototyping, to all the way to writing the code that sort of goes in the vehicle. And this is the part of the vehicle that the people interact with, these interactions. So like the speech systems and the gaze and the gesture systems, that kind of stuff, the stuff that you see on the screen and the intelligence behind that of when to show the right information and what do we show to the right user, and the learning, the adaptation that happens, the personalization, that's sort of under our sort of scope to help define and try to make the drive forward the capabilities of the system and ride that sort of wave of innovation, if you will.
Yeah. How do you feel about that being labeled as like the operating system of the car? Is that kind of where you operate?
Well, the way that I think about it is something of a decision maker. Because at the end of the day, you can think of the car as being an intelligent agent that is deciding to do things, vehicle functions. And usually this is in sort of collaboration and concert with sort of the user. And so in a sense, you can call it an operating system in the same way that sort of in a computer system, the thing that actually sort of runs the actual sort of code is going to be the operating system. But that's sort of in connection with the user. The user is not going to have a good experience if the operating system is sort of running the wrong things. Yep. And we can see that happen. I think Clippy 2.0 would be a very terrible thing for us to sort of get to. So I think it's a fair metaphor. At sort of the high level, certainly.
I'm old enough that I remember when a car was basically a steering wheel and two levers and then maybe some knobs for the radio.
Sure.
Much more sophisticated system now. Tell me a bit about the different ways that those interactions are growing. I mean, there's user interface everywhere in my car now. What are the different things that you get to play with?
What's the joke these days? That the car is more computer than mechanics these days. Even not even from the user interaction point of view, just even like a lot of the powertrain and the fuel sort of systems and like the mechanics of it are a lot of it's digital these days. But focusing on the user interaction, I think people are used to the idea of like knobs and buttons and wheels and pedals and this sort of thing. But you end up with this problem in UI that as you are adding more and more features for the vehicle, you have to expose UI for that. And there's really only two ways to do that. That's where you sort of increase depth of the UI. So, at each sort of layer of it, if you will, you have a sort of a stack amount of complexity, but you may have to sort of search for it, go deeper. So you may be used to like menu systems where you press a button, opens another menu, which you press a button, it opens another menu, and you press a button, and then you find the thing you want. Right. Or you make it more complex but flat, and so you've got one sort of interface which has got lots and lots of buttons. And I think the metaphor for this is something like the space shuttle cockpit, where you sort of sit in it and you're really surrounded to the right and to the left and to the top of just knobs and buttons, what have you. But a key realization that you can really have is that user does not need to be exposed to that much sort of, say, control and also that much information at any given time. People's brains can handle that amount of sort of information overload. And so what you really got to do is sort of be very smart about when you decide to expose the right information and what kinds of sort of controls that you offer and how do you dynamically sort of change that interaction to sort of be smart. And that's very personalized. Right, so it's not something that we can sort of in the lab sort of design sort of on our own and then give it to roll out to every customer. Every customer gets the same experience. It has to be personalized, has to adapt, has to be contextual. I'm going to show you at different sort of situations going on around the vehicle, different times of day, different sort of required cognitive loads. So if you're being lazy highway driving versus like, oh God, it's city driving and there's an intersection and this guy, this guy's come over from over here and there's a construction worker and the lanes are all painted differently. It requires a lot of cognitive load. Sure. And the amount of sort of interaction in UI you want to expose to the user, the amount of interaction you can demand from them is going to be different based on that contextualization. And this is not something, again, that we can sort of sit down in the lab sort of in, at our workplace and sort of map it out in design, and then every user gets the same experience. We have to learn this stuff. And so this is talking about looking at interaction data, people using the vehicle, people using our interactions, taking that data, learning about them, and then using what we learn about them to sort of expose these things to them and take action, sort of on their behalf.
Very interesting. I'd love to know more about that kind of pipeline. Tell me about that source of data. Is that car telemetry? Are there? Is my Mercedes? Now I don't have a Mercedes-Benz, but if I had one, would it make API calls back to deliver some information? How do you guys collect that?
That's a very good question, and I think that touches a little bit on the angle of data privacy. As a policy, a very, very strong policy we have in the company, we're very concerned about the sensitivity of the data that we use for these kinds of applications, and it's not enough if one data point isn't localizable. But if one data point is not localizable, then 3 might be. So if I have 3, I can still localize the data for like a particular car, a particular consumer. And so we kind of look at the data as a holistic thing and saying, look, the sum of all data from a single person, if we send that to the back end, we don't want that to be traceable to any particular car or user. Sure. And so there's a big sort of anonymization sort of procedure that kind of goes through before anything gets sort of to the cloud. But of course, that means that it's lossy. There's information being lost in that process. And so a lot of what it takes to do this highly personalized learning can't be done on this highly anonymized sort of data. In terms of like building out sort of ideal pipelines for this thing, is considered the hybrid approach. What's happening is you get this aggregated customer data sort of going to the back end, and that's helping sort of understanding typical human behavior, sort of as a whole, as a group of people. So here's what we know about humans in general. And we use this to do, here's some buzzwords, the manifold learning, feature selection, defining the priors for our Bayesian models, et cetera, sort of happens there. But it's really about not trying to understand particular customers, but just trying to understand general patterns in human behavior. And then what happens in the car is it sort of starts with that knowledge of the normal human behavior, which it gets sort of from the back end, and then applies to that the personalized stuff. So the data that we can't send back sort of lives in the vehicle, the very personalized things, and so are using that vehicle, it's sort of adapting that prior, if you will, with this likelihood term. So it's really a hybrid approach pipeline. We've got data being sort of streamed, anonymized data being streamed back into the back end. We're doing some learning on that. That ends up going down to the vehicle, and then the vehicle itself is then taking that individualized data and then roping that in and learning about my particular users, my particular owners of this sort of experience.
Oh, neat. So you get to do some centralized stuff on anonymized data, but there's actual machine learning
happening
taking place
in the vehicle,
privately in the vehicle.
Oh, yeah. And that's sort of our technical solution to the privacy problem.
Yeah.
It comes with it a whole range of sort of problems, one of them being, of course, model validation. So you have this sort of situation, that the typical machine learning pipeline is that sort of all this data lives on a back end somewhere, all of it together. You have some guys in a lab who try to fit models against it, and it's very iterative, where they try things and it doesn't work, and they try other things and it doesn't work, and they fiddle with it a little bit and tweak it and parameterize it, and eventually get in a situation where they're happy with it, and then they deploy the thing. And if problems end up happening out in production, there's usually some data pipeline where it goes back and sort of feeds the circle. They get more of this data, and they can tweak it again and sort of patch it. So they have knowledge of issues out in the field. They can fix that in the lab, and they can redeploy. When we deploy our stuff, of course, and it's getting that data is not going back to the back end. Right, by definition, because we don't send that because of the data privacy aspects of this, which means that the algorithm, in a sense, is on its own. In the sense, if it encounters problems or isn't exactly behaving the way that we would want it to, it has to detect this on its own. It has to do what it can to fix that. It has to do proper decision making. And this is important because in reality, we don't have a singular model trying to solve a single problem. We have a model that we're deploying, which is going to be faced with a slightly different problem depending on which particular user that it experiences. How can completely autonomously can you sort of determine whether the models are good, whether the models are bad? How good are your estimates for things? Am I being useful to the customer or not? How do I decide to take action based off of this? In the worst case scenario, a model sort of realizes, I am not providing value to this customer. Then you have to think about, the so-called kill switch of self-realization that the model isn't helping, so it has to fall back on sort of more traditional sort of UI motifs to give the sort of non-learning experience. Now, of course, you don't want to get to that, but it's really important to get the decision-making super, super, super good, so that can happen. Because when you're talking about automating actions, starting navigation routes on behalf of the user, filling with the climate settings, you get into the car and the climate settings are sort of already set kind of stuff. The customer didn't set those, we set it sort of for them. If you do that poorly and in the wrong context, you have the real potential to cause emotional, financial, or physical harm to the customer, and that's obviously a thing that can't happen. And so we put a lot of work in the research to make sure that when we take these sort of intelligent agents and throw them out into the field to go interact with our customers, we can sort of trust that they're going to manage themselves and not do the wrong thing.
So feedback's very important in learning.
Yeah, absolutely.
Obviously, some people will buy their next car from you guys as well, but that's pretty slow feedback. Whereas if I get in and you turn my AC up down to 50 degrees and I like it warm,
you're like, what the heck?
Yeah, how do you know that the customer liked or didn't like that scenario?
That depends on the specific use case, specific vehicle function. So oftentimes it's quite easy to tell when something has happened that the user doesn't like. If the car takes an action and the user immediately revokes that, that's immediate feedback that's very clear. What we're trying to do is trying to predict user behavior, but by predicting the user behavior, we've also influenced user behavior. Are they driving to this place because, do we actually predict that they're driving to this place, or are they driving to it because we predicted it? Because at the end of the day, the customer had it in his mind, instead of like 3 or 4 spots, like bars you want to go to.
Groceries, yeah.
It was like, I got to go to a grocery store, and the one that was on the UI that we sort of exposed for them may not have been his optimal choice, but him having to choose another one invokes going into a more complicated UI, having to dig down below sort of the current system being exposed to them. And so I say, screw it, we're just going to pick the one that's right there. It's suboptimal, but it's easy for me. It's hard to detect when you've done that because it looks like you presented something, the user liked that presentation, and they've gone with it. And so it looks great from you, but you sort of miss the fact that they were disappointed by the sort of interaction. A lot of our UI design is designed around making sure that there are tiers of things that we can expose based on our certainty. So there's the I feel kind of unconfident about this thing that I know about the user, so I'm going to show it along the way to the UI. So I may have an address entry screen somewhere for like a destination, and if I'm not particularly confident that I know where a person's going to go, then I might suggest a location to the side of the menu where that's happening, so they can still put in their normal address where they want to, and they can sort of see that I've got a suggestion there, and if that's convenient for them in this case, they can sort of press it and no harm done. So if we're wrong, no one really cares, and if we're right, that's just a nice little bonus. If I'm slightly more confident, I can be proactive, and I can say, hey, look, here is a box. I'm going to throw a dialog box or something like that, or I'm going to prompt the user, hey, I think you want to do this. Can you quickly confirm that for me or not? The cost that's a little higher because if I'm wrong, I've annoyed the user. I've had to make them. I've put this wall in front of the interaction for them that they have to interact with beyond just putting in the address. So you have to be a little more confident in your sort of knowledge before you do that sort of thing. And the very other end of the spectrum, I am extremely confident in this thing. We don't even prompt. We just do it. And in this situation where you see like a person's gone to work every day, 7 a.m. for the past 3 years, you can be extremely confident that tomorrow morning, 7 o'clock in the morning, he's going to go to work. And so if that navigation's already started, we can trust that. But of course, this is sort of heuristical, and of course, we do this statistically very rigorously. And we put a lot of time in making sure that, this isn't based off of wishy-washy, sort of like, it kind of feels good.
Sure.
One of my rules of my team is no magic numbers, so none of this like, 95% confidence is fine enough. It's any single constant that you define for anything, thresholds or what have you, have to have their backing in theory. And so we define these things to be extremely statistically rigorous.
I'm on the courses page at Brilliant.org. Let me tell you a little bit about what they have to offer. Specifically for data skeptic listeners, I can see where probability, physics of the everyday, logic, number theory, games of chance, probability, there's a lot of great courses here, linear algebra, computer science fundamentals, algorithms, artificial neural networks. Coming soon, advanced algorithms. I'm really looking forward to that. There's a ton of great things here of interest to everybody. I like the way Brilliant teaches. It's these very bite-sized selections of those courses. You don't have to sit down and commit to some 60-minute lecture. The sections of their courses are quick and easy. It keeps track of where you were. And there's all these integrated quizzes along the way to make sure you're getting the concepts. There's also a great Brilliant community. Check them out at brilliant.org/dataskeptics.
So in traditional kind of plain vanilla machine learning, you get your design matrix and then sort of your objective variable, and it's all very cleanly this row equals this value.
Right.
You guys, it seems to me, don't have such a clean input because users are constantly interacting in different ways. There's periods of no interaction. How do you tackle feature engineering and deal with the sequential nature of a consumer's interactions with their vehicle?
You mentioned the typical machine learning sort of example, and usually you're talking about one model. And the reality of it is that in this space, there are a multitude of models all sort of looking at different objectives, and they interact with each other. And you have to have like meta models which take as input these sort of more fundamental models. And so it's a sort of web. And we like to joke about it and call it sort of a car brain, because you have all these different intelligent pieces all sort of interacting and sending data back and forth, and the input of one is the output of another. So like predictions form other predictions, which define decisions that we make in it's a sort of nature. The way that you ground this stuff is you make sure you always tie your ends in things that are measurable, sensor inputs. We can see them talking with us, we can see them doing things with the cameras, we can see them pressing buttons, interacting with the UI. We have a lot of sensors, we can tell those sensor values, and so you allow enough sort of intelligence in the middle for it to reason about why all of these sort of sensors are doing the things that they're doing. But at the end of the day, you have to define your objectives in terms of things that the hardware can measure. That can sometimes be very challenging. I think a great example of this is the emotional space. A lot of behavior in the car can be driven by emotional sort of content. But there is no sensor that tells me sort of how you're feeling, right? And so I can't put a sensor on it and be like, oh, he's angry, so therefore this. And so what you kind of have to do is you have to look at sort of sensors which you expect to be correlated with like emotional context, and then UI-based behaviors which you expect to be correlated, and leave room in the middle for the model to do reasoning about emotions, but never really explicitly. And so you leave it sort of up to the intelligence to sort of figure it out. And so you might do something like doing music recommendation, rather than just using historical playing as one of your factors here to sort of learn, appropriate genres, etc.
Sure.
You can use a biometric sensor. So if I did something like skin galvanization or like heart rate, etc., and then try to find patterns in how those biometric things change in response to like music, then I can sort of see on some days I see a change in those very real biometric signals. And whether or not that's really emotionally driven in the middle, we can let the model sort of think about. But I think it's very clear to sort of convince yourself. A person comes in, they're tired, the heart rate's a little lower, the resting heart rate's a little lower than normal, and you can sort of tell that they listen to more mellow music. Then if they come back and they're sort of pumped, heart rate's a little higher, and they listen to more sort of upbeat music, you can find that pattern. And so when a person comes in, and we can measure that thing, measure the heart rate, and then drive the UI, say music recommendations around that, without explicitly ever saying, hey, look, this is based off of mood. It still really is at the end of the day, because the factors that we're measuring for real, like the heart rate, et cetera, are influenced by the mood. And so therefore, in this sort of indirect way, these latent things that we can't really measure, we can still kind of measure through a clever combination of what sensors we put in the car.
So I share a single car with my wife.
Yes, absolutely.
And every so often a stranger will be in, well, not a stranger, but like my sister might drive it.
Sure.
Uncommon driver.
Right.
Are you able to take, kind of detect the pilot and work that into the personalization?
User identification's a big thing for us. And so it's extremely important that we, don't drive the UI, make the right actions, or show make actions, make decisions, or show different UI elements that are sort of for the wrong person. There's an annoyance factor involved, but more importantly is like the privacy factor. And I think an extreme metaphor for that is also the mistress use case. You don't want to expose the mistress to the significant other, if you will. I don't know why that always comes up as the example, but it's an example. You want to make sure that you do the user identification stuff extremely well, because the potential for harm, again, if we show the wrong content to the wrong person, is extremely high. As you can imagine, there are a number of things in the vehicle which we can correlate with user identification or user identity. There are the so-called hard sensors. So these would be things like camera inputs or partial fingerprint sensors as you touch surfaces, are things that are very clearly sort of useful in this context. There are a lot of soft sensors. So things like broadcasting Bluetooth devices. So if I see that your phone is in the vehicle, it's correlated with you being in the vehicle. It's not a hard thing. It's easy for you to lose your phone. It's easy for your phone to be stolen, but it is correlated. It's useful information. It's a piece of the puzzle. We can also look at key IDs. You and your significant other might have different keys. That's information we can look at. We can look at weight sensors potentially, because we have weight sensors in there for the airbags already. So that's information that's potentially correlated. Behavior is potentially correlated. If I know, if you're the 7 o'clock in the morning person every day at work, and this morning you came in at 7:45, even if a lot of the other sensors sort of tell me, it's probably Bob or what have you, but the behavior is different. Something's weird today. Now I'm going to be a little less certain and making, I'm going to be a little more conservative and cautious because this smells funny. You know what I mean?
Sure.
So the idea is that we want to take all of these bits of information, the hard and the soft, and sort of combine them together to get sort of a rich sort of inference over who it is that we think is present in the vehicle. If we are extremely confident, we can just take action on that and not worry about it so much. So if it's your fingerprint and it looks like you and it's your behavior and it sounds like you and everything just aligns, then great. We don't have to worry so much about exposing that behavior. If something smells a little weird today, we're not as confident, maybe you don't have your phone on you today, or maybe, you haven't shaved in a while and so the face isn't as clear, then maybe when you try to access some that's a little bit more private or a little bit more sensitive to leak. We might put in a, hey, look, please put your finger on the fingerprint sensor, or hey, please enter some password or something along those lines to sort of confirm that identity. An extra step to sort of make sure, which we're not going to require when the stars align and everything looks kosher.
Yeah. So when your team comes up with a discovery, the research yields something that looks really promising, you want to incorporate into the product.
Right.
How do you do model deployment?
We're constantly doing research, and we're looking for ways to push the field forward to enable things that weren't previously sort of possible. And that usually leads us to building proof of concepts or prototypes. So we'll start with benches or something along those lines in the lab that we can interact with, and eventually that makes its way into sort of skunkworks cars. So we have prototype cars on the road with some of our prototype systems, so people are using those sorts of things, and we're doing model validation on that. Eventually what ends up happening is once it's gone through sort of the whole pipeline, we write the code that goes into the car, and it goes through the normal production sort of series. So our team sort of end to end is responsible, like I said before, from doing the fundamental research to all the way to writing the code that goes actually into the system. So there's not really a place where we do half of it, then hand it off to some third party to sort of finish up. We take it all the way to the goal.
Very neat.
So making sure that it's the same people who develop the methods are sort of the same team that are responsible for making sure it's sort of done correctly in the vehicle.
And are you able to, when you have a novel result, as you mentioned, there's a lot of important steps to make sure it generalizes and validates and so on
Absolutely.
and so forth. But when you've really nailed it, is it like you send Python code to my car over the air, or what actually happens?
No, I mean, today, it's old style. We write code, it goes to the factory, it's part of the flashing process, and the new cars coming out will have that code in it. We've been talking about the over-the-air update thing for at least the last decade.
Yeah.
And I can talk your ear off about the status of that kind of stuff. But that's not where we're at in production today. Those conversations are happening, and I'd love to get to a point where it's as simple as, we have in the lab and we like it, we press the go button and now it's in my car. But the way it works today is that when we like it, cars that are being made from then on will include this code.
Are there any features you guys have created you're especially proud of? You want to share maybe some that set you guys apart, or just really novel ways that the car driving experience has changed as a result of some machine learning?
So one of the problems I think in being in research is that you're always living slightly in the future. When you're working on like 2020 cars, 2022 cars, the answer is always like, I'm always super stoked about what we're doing for like the 2020 cars, but you can't talk about that.
Got it, yeah.
And so, the stuff that's sort of out this year, you look back on and you go, at the time that was really good, but we've got better now and it's going to be better. And so when you're asking like, what are things that I'm proud of and things that are like really, really exciting, or of course the stuff that I can't talk about, the stuff that we're doing in our cars that are released next year and the cars in 2020 and et cetera, are the things that have me most excited. But one of the products that we've got in the market today that I can't talk about, that I had a very sort of personal hand with, is a lot of our destination prediction sort of work. So what we do there is we look at when a person drives to what sort of destinations, under what contexts. We can predict that. This example use case I gave before of going to an address entry screen and having that suggested place where you just click it rather than having to actually type in the address. That's actually part of that product, and that's released today. Those things can be automated, so you get into the car and the routes to sort of start it is based on this sort of confidence intervals that we have, and that's stuff that's extremely sort of recent from a production point of view. When I look at the company, there's been a big shift in agility and trying to innovate faster, trying to get things out to production faster. The automotive industry is famous for having these extremely long sort of product timelines.
Yeah.
Because there's a car involved.
Well, it has to be at some level.
It's not software at the end of the day. It's an engine. And so, yes, we put software in the car, but if the way it works is that you wait for the car to release, and then whatever software we have available sort of gets put into it, then you're waiting on like a 5 to 7 year timeline. But there's a lot of change into questioning that sort of business model and figuring out ways for us to push updates a little faster and decouple certain components of the car from each other, so that even if certain things do have to change on a 5 to 7 year, not all of it does, and so we can push that out on a more reasonable time frame. And so I think then we're not going to have the situation where year 6 about to be year 7. So we just had 6 years of like the same experience, about to have this brand new car line be released, and we don't want to talk about that because it's going to hurt our year 6 sales. And there's this big gap between it. To really, the gaps between iterative releases should be a lot smaller, and so. It should be really more apparent to sort of the customer the rate of this sort of stuff, and they can be the judge if they want to wait another 6 months to see like the next iteration, or if they want to commit now, or wait 6 months and then buy the previous iteration, or whatever kind of business model that ends up being. But I mean, it's not so dissimilar from the phone world.
Yeah,
right?
definitely.
Do I buy a phone now, or do I wait for Apple to release the next one in 3 months? Is
Right.
I think a very real question consumers have to ask themselves, and I don't think from a consumer standpoint there's a very clear optimal decision to make.
To wind up, what's the main motivation for you guys to come have a presence at NIPS?
That's a very good question. So we've attended NIPS for the better part of a decade.
Mm-hmm.
So we have a lot of researchers that come here. We're just part of the community. This is the first year that we've sponsored. I guess one of the primary motivations for that is recruitment.
Mm-hmm.
So we have a large number of open positions in a lot of our different sort of AI divisions.
Mm-hmm.
And so this is a really easy way to sort of get attention. And a lot of guys who come here are pretty top talent.
Sure.
These are some really smart guys. And so it's really a good way to sort of get your name out there and attract that kind of people. And part of it, I think, is also sort of giving back to the community. The machine learning community is exceptionally open from a model perspective. And so, you just looking around the conference right now, all the companies that are here, you've got IBM and Intel and Google and Uber and all these sort of places, they're here because they have research being published at venues like this. And that sort of means that when they come up with something new, they don't hold it close to their chest and sort of keep it there. They sort of release it out into the open. And what's great about that is it means that other groups can take that, iterate on it, make it better, and then re-release it. And so, if you're part of this community, you sort of realize that sort of being part of the community, giving back to the community is actually going to help your business at the end of the day, because it means it's not just you in your corner working on your product, but really you're opening sort of the product development and the innovation to a broader community, which is also helping you sort of make the best possible products. We're all sort of collaborating together to really push forward what intelligence can do. I think a lot of companies out there stand on the shoulders of giants.
Mm-hmm.
They take a lot from the research that comes out of venues like this.
Sure.
It's important for us to sort of recognize that and sort of realize that we then sort of owe a debt to the community to sort of give back. And so this is sort of, in a small way, our way of doing that.
If people want to follow you or learn more about your team, where can they go online?
We have a Facebook page. We have an Instagram account. We have a web page. So we're present in all the major social media. A good search for Mercedes-Benz Research and Development will uncover those sorts of things. I think people who are good at their Google foo will not have any trouble at all finding our social media presence.
All right, well, Rigel, thank you so much again for taking the time to chat with me.
Thank you so much. I really appreciate it.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.